Great. Well, it's thrilling to be here right now. This is an awesome crowd that's come out. I'm Rob Coneybeer, as introduced. I'm a managing director at Shasta Ventures, and I focus on emerging platforms. Robotics is a big part of what we look at in emerging platforms, and obviously self-driving vehicles are a part of it. We have an awesome panel lined up. I don't know how many of you are really familiar with what's going on in autonomy right now, but we have 3 major OEMs, the heads of their autonomous businesses. We have NVIDIA here, who is working with well over a couple hundred automotive companies around autonomy right now. And then we also have one of the leading and most highly funded automotive startups, Drive.ai, as well. So what I'd like to do is ask each of these folks very quickly just to introduce themselves.
Thank you. I'm James Kuffner. I'm the Chief Technology Officer at the Toyota Research Institute, also adjunct professor at Carnegie Mellon University.
Thanks a lot, Rob. I'm Glenn Schuster. I run the technical marketing team for our automotive business at NVIDIA.
I'm Ka-Seng Tae, the VP of Engineering at Drive.ai.
I'm Nick Sugimoto. I'm the CEO of Honda Innovations, Honda's open innovation arm, actually located right next to Drive.ai.
Dragos, Maciuca. I'm the technical director for Ford here in Palo Alto.
So this is a general robotics day, but one of the things that we were talking about that we wanted to ask the audience to kick this off is, how many people understand and know what level 5 autonomy is for driving? Please raise your hand. Like, be really high. Hold it up really high. Okay. So it's a pretty big part. Keep your hands up. Put them back up. Okay. Now, put your hand down if you think that it's going to happen in the next 5 years. Next 10 years? Next 15 years? Next 20 years? Okay, so there are a few people. There's somebody in back who thinks that it'll be more than 20 years. So you get a sense here for how many people are familiar with it. Maybe before we get into answering the specific question of when, if somebody on the panel could just quickly explain the difference between the different levels of autonomy for people that might not be familiar with it. You're the professor. See, everybody understands. Okay. James?
I think the most important distinction is level 5 and level 4. So when we think about level 5, the basic explanation is, can you build a system that is a drop-in replacement for a human driver that's able to drive under any condition, any weather, any traffic, under any environment? And as you know, there's a lot of technology problems to solve before we can actually do that. However, if you start to constrain the problem, you say fair weather, a good map, light traffic, a dedicated road, then suddenly you constrain the problem enough, and any constrained version of level 5 is level 4, where the car does all the driving for you, and you could essentially fall asleep in the car if you wanted to. If you constrain the problem enough, then you actually get much, much more aggressively closer timelines to launching products.
And just very quickly, when you say any conditions level 5, is that kind of like the Tahoe test, where you could actually go to Tahoe, you could wait, you could have somebody put chains on your car for you, and then it could get through snow and ice to your destination?
Right, the robot would actually get out of your trunk and put the chains on for you. But yes, I think that's one good summary of it is snow, ice, rain, fog, heavy traffic in rush hour.
So maybe putting this slightly a different way, it sounds like level 4 in a lot of ways is what we're looking for. And Dragos, I think Ford has announced that they would have level 4 vehicles available for purchase or for testing by 2021.
So what we've announced by 2021 is that we'll have level 4 in select urban areas. So the way we're looking at it is basically robotaxis in several major cities, but they will be mass produced. So we don't think the first release makes sense to release it to the public for a variety of reasons. Cost being one of them, operational and trying to understand how they work being another one. So we're looking at various ways we can release robotaxis as a fleet in several major urban areas. We haven't decided yet exactly the format or exactly the cities, but that's what we plan to do by 2021.
So Glenn, I think I'll put you on the spot here, and you got a sense from the people in the audience how and when people think the Tahoe test will be actually, there's a Turing test and there's the Tahoe test. This is a Tahoe test. You're working with hundreds of automotive companies around this. What do you think and how do you react to the way that people characterize when they think level 5 is going to be available? And what are the technology challenges between here and there?
Yeah, I think a lot of the feelings out there are perfectly accurate right now. The developments around level 2, level 3, level 4 have real timelines. They're out of research and into development. Level 5 is still very much a research topic. There are lots and lots of companies, probably half plus of the 200 some odd that we're dealing with are all researchers. And that's everything from researching a high quality path planning algorithm to companies still just trying to research level 5 autonomy overall, going straight to fully autonomous and trying to figure out all of the problems associated with that. So yeah, the 5-year timelines that a lot of people are talking about now are very much around level 3, level 4. When you get up into the fully autonomous, go anywhere, that's going to be a much further timeline.
So it sounds like, maybe to summarize, and looking at the body language here, and if people disagree with this, please say this, but the level 4 stuff, maybe robo-taxis in cities, dealing with a lot of that could be 5 years out. But when you start to think about something that could really drive anywhere, there's going to be a long tail where you have more and more capabilities, but that could last 20, 30 years.
Yeah, I would add a couple of things. We were just talking about this. I did my PhD thesis in '97, to date myself. And a ton of fully autonomous vehicles were supposed to be 20 years out. And they were supposed to be 20 years out since the 50s. So basically, they're always 20 years out, but on a rolling basis. So to some extent, yes, they're still 20 years out. The other thing I found interesting is when we talk about level 4, especially for this audience, is that we have actually been approached by a couple of Japanese ministries. The thing that's interesting is that we here are trying to use level 4 in major urban areas because of the economics. There, the interesting thing is that they're actually trying to use it in rural areas that are not well populated because a lot of the younger population has moved to the cities, and it's too expensive to bring in a train or a bus, and then they're looking at using autonomous vehicles to take the elderly to shopping or the hospital. And so I think it's fascinating that you can have completely diametrically opposed uses for the same technology.
So when you look at level 4, and we're talking about 5-year time frame, and it sounds like people largely agree with that on this panel. Would you, yes, nod, yeah. So who will be buying that? Will it be individual consumers that think it's great because they go in the city and they turn it on and it drives them around? Or will it be the Ubers, the Lyfts, the individuals or companies that want to deliver the robo-taxi services you were talking about? What's the business model piece?
For us, that is the business model. At least in the very beginning, it will be some sort of fleet operation. We don't think it makes sense to sell it directly to the consumer for the first generation.
Yeah, at Drive.ai, we believe as well that businesses will be the best customer right now because the price points of these vehicles with the sensor costs and the AI cost itself for the software itself, businesses will be able to kind of recoup that investment through the utilization of the vehicles. But consumer cars, you drive it 2-3 hours a day. Most likely, you wouldn't want a car that's looks ugly and it's really expensive at this point. So we believe the next few years it will likely be business customers, fleet operators, other owners of large number of business fleets.
So, James, you were involved with one of the very earliest efforts, right? You were before it was even X at Google, right?
That's right.
So how have you seen conventional wisdom change about when we should expect these cars and what the business models are likely to be?
I think a lot of us that were part of the original Google team, now Waymo, who were pulled in from the various DARPA Grand Challenge and DARPA Urban Challenge teams, saw advances in perception as being the hardest part, scene understanding. I think technology has dramatically improved. The other thing that's of course improved is compute power and deep learning and big data. But when we talk about business models, it's already been brought up, but I do agree that mobility as a service, automated taxi fleets make so much sense because perfectly complements level 4. If the weather's bad and the traffic is bad, or there's terrible road construction, you can send out a human driver. But if the weather's great, you have a good map, geo-fenced area, and traffic is light, send a robocar. And then because of the high utilization of the vehicle, you can amortize the cost of the sensors, and also you can have a fleet managed that makes sure everything's calibrated and well maintained. So for all of those reasons, I think that really has been the evolution of thinking of the business model, as opposed to just a black box you could put into your personally owned vehicle.
Well, I guess even when you were getting started, Uber wasn't really anywhere, right? It didn't even exist. It was just taxi cabs. So people hadn't even thought about that model yet.
Right. And, we did a lot of iteration and studies, while I was part of the Google team. And, of course, a lot of other good researchers have been looking at and exploring this problem space for a long time. But I think what we're realizing now is that there's also tremendous opportunities as this technology matures to make transportation much safer and give access to everyone. So that's also in parallel to exploring these new business models with mobility as a service and driverless taxis. We're seeing how this technology could also be deployed on personally owned vehicles to provide safe access to transportation and mobility for everyone.
Yeah, the other big area that we see quickly following the robotaxis is the trucking industry. There's a worldwide shortage of truck drivers. They have a built-in business model. They need to get products from point A to point B, and we're seeing fairly strong demand in that area as well. But again, it's still very fleet and business driven as opposed to consumer driven.
Yeah, it is amazing. And I don't know if this has been a theme earlier today, but when you look at automation and robotics, people always worry about where are the jobs going. But the reality of where robots go first is where you can't find people to do the jobs. Because it's something like 50,000 jobs that are available in trucking today. They can't fill it. You can actually get paid well. If anybody here is looking for a job, there's a truck with your name on it right now. So I think that's actually a good transition to thinking about government policy, because people think about jobs, et cetera. One of the things that I've seen as an investor that's been a bit surprising is governments in general and states in general seem to be a lot more permissive of testing than I ever would have imagined. And there are some states that are even more aggressive. You have Nevada that makes special plates, the Infinity plates, I'm sure you guys have seen, for autonomous vehicles. What do you think government's role is going to be here, and what do you think is the most important part of government's role in terms of enabling this future that we're talking about?
I'll take a crack. I mean, for us, the ideal case would be to not have 50 different regulations as you drive across state lines. So, it's one thing that, again, you said the states are very progressive, but it'd be good to have something at the federal level where we can have the same regulations across the entire country. That would certainly help a lot.
Actually, Japan is pretty aggressive in introducing self-driving community. Coming Olympics 2020, they just announced they are going to introduce totally self-driving traffic system in Tokyo, which is very challenging, but all Japanese car OEMs are shifting gear toward it. So yeah, in the US, probably federal doesn't really lead that way, but in Japan, Japanese government is really investing a lot to make that happen.
Yeah, it's pretty remarkable when you look at it. It seems like some of the states are like, hey, if you want to start driving cars without safety drivers, we'd be up for it. Kind of surprising. So maybe towards that end, one of the things that almost seems to be the dirty secret of a lot of autonomous vehicle testing that goes on today is there's always that poor soul who's the safety driver, right? I mean, it's probably one of the worst jobs available anywhere in the world today, because if you go and you actually interrupt the vehicle's operation, it's almost like a black mark on how the vehicle is doing. So you want to let it go until the moment that something truly bad is going to happen. How long do you think it's going to be until we actually see some sort of deployment, even a test deployment, whether it's maybe you could speculate against, about Waymo since you're not there and not comment on TRI. But when do we see the first time that you see a car going down a road and literally there is no safety driver? There's just somebody in back getting a ride.
Well, my Google colleagues, we had on the road a blind passenger without a safety driver riding the car.
Oh, is that the Taco Bell
yes,
video? Okay.
yes.
Are people in here familiar with the Taco Bell video? Raise your hand. Okay, this is really important. They did a video, and this was like 4 years ago, where a blind person got in a car, and it took him to Taco Bell through the drive-thru, and it was his first, I think, drive-thru Taco Bell experience ever.
Yes.
Okay.
But of course, they did a lot to make sure that was safe. They had chase vehicles and all kinds of things. But I think what is important is that safety should be the number one way. I think we have a moral obligation to make sure that the technology we build is safe. And so there's this balance of trying to push the edge of innovation and get the useful data you need in order to perfect and test and vet the system, at the same time be conservative in terms of pushing that envelope. So I think that's always going to be a trade-off, but I think the government can help play a role in terms of making it so that there aren't a patchwork of regulations, and we do have sort of some national standard because these vehicles are going to cross state lines.
So for the audience's benefit, what is the statistic that has to be reported today about how safe or effective an autonomous vehicle is today? What's that metric?
So I can speak, in California they have pretty well-defined metrics that they report, disengagements and number of miles and sort of disengagements per miles. At TRI we're thinking about replacing that or proposing a new metric that we could use, because there's this strange perverse incentive that happens that we actually want our engineers to be stress testing the system before it goes out as a product. And if you are avoiding those situations just so that you can have more miles per disengagement.
Just so you can get better statistics.
Yeah,
it doesn't make it any safer.
Exactly. And the other thing is that not all miles are created equal. Let's face it. If you report 1 million miles with one disengagement in an abandoned highway in New Mexico, as opposed to 1 million miles in rush hour in Manhattan, it's a very, very different capability.
Or driving through India. Or,
exactly.
Okay.
Exactly. So I think actually a new metric that we've been working on at TRI is around a weighted average of distance and capability. So difficulty weighted average of miles. And how do you score the difficulty? That's actually an open problem. I think it has to do with weather and traffic and all of those things.
So when do we know, say, Dragos, when are we going to know that it's safe enough? Is there a moment that you have in mind or Ford has in mind for, you know what, it's ready for deployment, even in a limited case like we've talked about?
Yeah, we'll get to that point eventually. I don't know, we don't really have that metric yet, and I think we as a community, as all the OEMs need to figure that out together with governments, but I don't think we're at that point yet.
Go ahead.
But technology-wise, it's relatively easy to define. But, the ratio of failure on the S-curve where you are. But, I agree. The society, is the society quite ready for that? That's another question we need to answer. Today, maybe or maybe not. But Waymo just announced their early rider program in Phoenix, and looks like there's a lot of excitement.
It sounds like to a certain extent, we do live in a capitalist world, so maybe it ends up getting defined by people that are willing to insure the vehicles or not, ultimately. Because you could look at whether the government says it's fine or not, but the people that have to underwrite it and deal with the lawsuits are the ones that are probably going to say to the attorneys at any of these major companies whether it's time or not.
Exactly.
One of the concerns is, I think from a perception point of view, is that even though we could save probably 90% of the people that are getting killed in car accidents today, you wouldn't know who those people are. So it's almost like you're not getting that moral credit for the life saved, because there's nobody to give you that reward. It's almost like autopilot for airplanes. You don't know the life saved because of having an autopilot, but you do hear about the eventual crashes when a couple of people get killed. And that's the concern.
I think some people feel that, I guess, when the threshold of self-driving cars and their accident rates maybe get comparable to human drivers, maybe that's when insurance rates will also kind of match due to liability claims and all that. Maybe it gets lower, but that could be one tipping point perhaps for when it gets safe enough.
So a different question. A lot of people, when they think about self-driving cars, they think about the safety driver. You take the safety driver out. I'm surprised that there's not more talk about how do you incorporate teleoperation into autonomous vehicles. And I wondered if anybody on the panel has some thoughts on either A, it's not going to happen for any number of reasons, or B, it's a natural evolution to go from having a safety driver in the car to somebody that's watching it like a drone operator to full autonomy.
I mean, you already see some of that in there are a bunch of startups more on the trucking side they're actually looking at it exactly from that point of view. So the hard operations at the beginning through the yards and through the ports being done by teleoperation, and you have basically one driver operating 10, 20 trucks, and then you let them fully autonomous on the highway. So there's definitely some of that thinking.
And some of it is also dependent on just connectivity, right? Getting connectivity in a port area or a trucking center is relatively straightforward. Getting connectivity, nationwide on all freeways, a lot harder, right? And so some of it is just the physics of deployment of connectivity.
I think that's absolutely correct. In the academic community in robotics, they have this concept of shared autonomy. And I remember an example when I was collaborating with a Korean company. They were doing voice recognition for in-car navigation and concierge. And, back in those days, everybody remembers, voice recognition didn't work that well. And sometimes it still doesn't work that well. But it's gotten incredibly
Sounds like
better.
a married couple.
Yeah.
Been married for 20, 30 years.
But they had an interesting system where basically you talked to the car, you said, this is where I want to go, and it was setting your nav system because, of course, it's very dangerous for people to be setting their nav system while they're driving. So if you could just talk and say, this is where I want to go, and your nav system would set. And so you would say the command, it would go to a server, and the voice recognition would come back and then repeat what it thought you said and ask for confirmation. Now, if you said no and you said it again, and then it failed again, the third time it would actually simultaneously place a call to a human call center who would listen to your recorded audio and remotely set your navigation. So that at least, you only had to do it twice before you had a human come in there and fix it. And so if it only happens 3% of the time, or and then the great thing is that on the places where it fails, you have a labeled data set now. You know that your speech system failed, and so now you should take that, label it, and send it back into your training system and retrain your machine learning. So hopefully, over time, the number of calls to the human call center fallback don't happen. I think there's lots of different technology areas in robotics and self-driving cars where this type of a scheme could work.
So I want to follow up on the training data, but I want to point out, we have this unbelievable panel here. We have people that have been involved with the creation of autonomous vehicles going all the way back to the grand challenges. We have 2 microphones at either side of the room. I've heard this is a shy group, but I don't believe that. So if you have a question, any question at all, I'd encourage you to get up and walk over to one of these mics, and I'll definitely point to you, and we can ask them any question that's on your mind. I have plenty of questions to ask you guys, but this is a huge opportunity, so any questions, come on over. So following up on the training data, and you think about government policy, et cetera, every car that is out there on the road and has the cameras and LiDAR, et cetera, is going to be gathering data, and it's kind of going to know when something almost went wrong and when things went well, et cetera. Do you think that that data should be shared with government agencies and shared between automakers, et cetera, so that you can make the overall system safer, faster? And I won't ask an OEM because I think you probably have dogs in that proverbial fight, but I'll ask our representative from NVIDIA what his
That's awesome.
general
By the way,
thinking is,
everyone
maybe
else-
what the questions are.
Everyone else on this panel is one of my customers. Yeah, fundamentally, training data is probably one of the most protected resources in the industry today. It is not something that people are sharing lightly. You asked the question of should. Some of it is shareable, some of it honestly isn't all that meaningful. And so it very much depends on the situation, but I can tell you predominantly today it's not being shared.
At Drive.ai, what we have learned from talking to different governments on a global scale are that some of the governments really do want that data for better safety, for I guess finding other kinds of crimes and whatnot. But I think we as a company may not be quite ready to share that yet. And I think at this point, everyone's just kind of figuring out what to do with this data and how much we share, how much we collaborate with it, etc.
Well, I think it depends. What for maps, 3D high definition maps, it's a infrastructure we all want to use. So maybe, and also Japan, there is a joint venture already formed across different OEMs building all high definition self-driving map for Japan market. So for that part, yeah, maybe that's an area we can collaborate to build the infrastructure together. But training data, that's probably the.
I know it's not an easy question because as an investor, I look at it, and on one hand, I'd love to see it because you could argue the industry would move along faster. But on the other hand, if you don't have the ability for a company to be able to develop a proprietary advantage to make their product stronger, better, more attractive, it won't attract as much capital, and then the industry won't move forward as well. So it's a hard trade-off. Okay, so we have a question over here.
Hi, I have a question for everyone, but maybe especially for James and then Glenn. In order to achieve autopilot, I think we need really high computer power. So either it's gonna be just like inside of the car, like a GPU type computer power can achieve it, or cloud computing, it should be somehow it has to happen to get it to make it happen.
I'll jump in on that one. Back to the connectivity conversation that we had earlier. Most companies that we deal with just don't believe that there's enough fully connected time to rely on the cloud. And so most companies are putting that compute power into the trunk predominantly. And depending on the type of environment you're driving towards, traffic jam assist, staying in your lane on the highway at limited speeds is not such a high compute problem. Right. Navigating downtown San Francisco or any large city is a very high compute problem. And the standard deviation amongst our customers is scary large. It ranges from hundreds of gigaops to literally hundreds of teraops. It's a very, very large range.
Okay.
I would say that when we think about cloud robotics, something that's near and dear to my heart, I've always advocated for not putting system critical or safety critical functions where there would be a network hop. Essentially, it's I've related a cloud-connected robot or a cloud-connected self-driving car to your cell phone. If you have no data connection, you should be able to still make a call, but it's much more useful if you have a data connection. And I think that's the same can be true of a robot or a cloud-connected car. The other thing I'll say about compute, our CEO Gil Pratt likes to quote that the human brain, I think, takes anywhere from 30 to 50 watts. Probably most people at 30. But let's say that 30 watts of power for the brain, and of course that's a level 5 driving system. Right now, most of us are building prototypes that are 3,000 watts, or so 100x. So I think when we talk about compute requirements and memory and power, we're going to see that aggressively, start to come down. We know we have an existence proof of something much more energy efficient.
So we have about 4 minutes, so let's take a couple more questions. Go ahead. And could you introduce yourself before your question?
Sure. So my name is Richie Goyal, and I work at IBM Watson. So we talk a lot about internal robotics, and especially in the self-driving cars, about being safe. My question is, how do you think of the security? Because these are devices which are going to be autonomous and running. How do you know that people are not going to take advantage and turn into a terrorist threat or something like that?
Yeah, I'll start with a hackable system is by definition not safe. Yeah, cybersecurity is a big part of the technologies that are involved in the self-driving world. It is yeah, very important.
Yeah, I suspect you're not going to get an answer that's going to be super helpful here, except that everybody on this panel would agree that it's a big deal.
I'd like to share one anecdote. So when I was a grad student 20 years ago, there was a seminar right when the internet was taking off, and a very well-known professor stood up and said, "Internet banking will never happen because the cybersecurity problems are too hard." Of course, nowadays, if your bank doesn't offer internet banking, you are leaving and going to somewhere it does. So I think these problems are really, really hard, but I think that we should be optimistic and it shouldn't hold back the technology.
So we have time for one more question. We have somebody else, I think, that's stepping up here.
Hi, thanks for taking the question. My name is Ramesh Rao. I'm part of a team from DreamView. We make depth cameras. They're out there. So last 2-3 years, I spent time in India, and all the hype and excitement is here as far as driverless cars are concerned. But I'd love to see these kind of cars in third world countries because the stress is too much. Do you see it ever happening? Because it's a nightmare over there.
The question being?
Can you really have driverless cars working in places like Vietnam or India or whatever?
That sounds like it's about 50 years out. Although they don't have to go that fast.
Yeah, I mean, I think there are multiple levels to think about this. One is like whether removing the driver makes sense in some of these countries where labor costs for drivers, may actually be cheaper than a self-driving car solution. Another is like the complexity of the road network and the pedestrians or cyclists around. I think there's some urban centers in some of these countries that probably have environments that will meet the definition of a level 4 and would be possible to roll out some things like that.
Yeah, I mean, I think on the spectrum of deploying practically level 4 systems, there is a range and there is an ordering. And clearly, like, deploying self-driving cars in Mumbai is going to be a lot harder.
Yeah, that said, but one thing that is interesting about this question is that when you think about active suspensions and technologies that can be placed on robots, cars, to make the ride smoother and better and compensate for infrastructure that's not as advanced, you could actually argue that it'll come along a lot faster than you think in a lot of these geographies, second world, third world geographies than people think, because it'll be very applied. So anyways, thanks to the audience for engaging, and please join me in thanking our awesome panel.
Thank you very much.
Thank you.